Hello students. So today we will continue the discussion on the ecosystem service evaluation. I hope you enjoyed yesterday's class. So you remember what we had discussed yesterday. We talked about there are four categories: biophysical, economic, socio-cultural, and the last one we said, as it's a very complex system, integrated one or hybrid approaches. So today we'll be discussing economic, socio-cultural and integrated one, which we could not discuss yesterday. For the economic valuation models, we have picked up total economic value model for detailed discussion. There will be a case example for that. Similarly, for socio-cultural valuation model, we'll be discussing in detail social values for ecosystem services, SOLVs. And integrated valuation models for ecosystem services, here we will bring back TEEB, the economics of ecosystem and biodiversity. And each one of them we will have a good case study to understand the application of that model appropriately. So for the economic valuation models for ecosystem services, you can understand there are so many different models available, but some of them let us have a discussion, and as I said earlier, total economic value we will discuss in detail. So market price method, production function approach, avoided cost or replacement cost, travel cost method, hedonic pricing methods, contingent valuation, choice modeling, benefit transfer method. So we will be discussing each one of them very briefly, so that we do understand if we need its, if we understand its significance and application potential. Whenever you will be requiring them, you can go back, you can read the references and you can understand them in depth. So the first one is the market price method. What it measures? Values of goods and services traded in markets. And the approach it uses is observable prices multiplied by quantities. It is used for something visible, tangible, like timber, crop, fish, fuel, wood. Required data, market price we need, production quantity we need. The limitation is it misses non-market services. And the typical formula, as always we know since childhood, you go to the market or shop, the value of something will be the price of the individual one, and if I am taking the multiple quantity. So that's the value. So it's a very direct one, market price method. The second one is the production function approach, which measures contribution of ecosystems to marketed production. Approach utilizes is it models relationship between ecosystem variable and outputs. So production function approach is used for pollination, soil fertility, water flow for agriculture, etc. The data required are the biophysical variables plus the yield data. It requires complex ecological economic modeling. So the change in value depends on the change in output multiplied by the market price, where output is a function of ecological variable. So that's the way it becomes slightly challenging, which has been mentioned under the limitation. Next set of economic valuation models we'll be discussing is the avoided cost or replacement cost. It's a very important one. So many times you will find its reference. Cost avoided due to natural ecosystem services that it measures. How it does that? It calculates avoided damages or cost of replacing service with artificial means. Best used for flood regulation, water purification, erosion control, like that. If you don't do it, then what can happen? That is the fundamental concept for this avoided cost. Required data, engineering cost, damage cost data. Limitation it has, that is, it may not be equal to true economic value. It will be within a range. How we do this valuation? cost of damage avoided, or we understand cost of artificial replacement. That is the two different aspects through which we can evaluate avoided cost or replacement cost. The fourth one is the travel cost method, recreational use value. It uses the cost or time spent by visitors to estimate the demand curve and willingness to pay. This is very important, willingness to pay. Sometimes people are willing to pay anything if that particular service is very interesting, very unique. Then this willingness of pay can be different. This travel cost method is used for parks, beaches, bird sanctuaries, for these type of experiences. Required data are the visitor travel cost, time cost, frequency, how many times in a year. Many of the parks in Europe will give you that type of facility. You purchase a particular card, throughout the year you can visit them for multiple times. So they calculate all these travel costs. Limitations, complex for multipurpose trips. Consumer surplus is the demand curve minus the actual travel expenditure. That's the way its value is calculated. Fifth method is hedonic pricing method. It's a very commonly utilized evaluation method. What it measures? It measures the value of environmental attributes embedded in property prices. Regression isolates contribution of the ecosystem variable. That's the approach it uses. It is best used for air quality, noise reduction, green space. Like, I don't know, in India somehow hedonic pricing is not probably that strong. If it was, then Delhi, Gurgaon, how come they can really fetch that high real estate prices? Required data set, real estate prices, environmental variables, these are the required data. The limitation is it requires large data set and it has also its own valuation method using formula. Contingent valuation method, CVM, is the next method we'll be discussing. It measures stated willingness to pay for protection or improvement. Through survey, you ask hypothetical willingness to pay. That's the approach. It is best used for biodiversity, cultural value, bequest value. We'll be discussing bequest value at least in details. And the data required is the willingness to pay service. It's having its own bias, hypothetical bias, and it is again having its own way of calculating. Mean or medium WTP multiplied by affected population. The seventh one is the choice modeling. It measures the value of ecosystem attributes via trade-off choices. The approach it utilizes is the respondents are choosing between the bundles. So WTP derived econometrically here. It is best used for the landscape quality, water quality, habitat diversity, like that. For this choice modeling, you need data like attribute levels data, survey data, and econometrics. It has its own limitation. It captures the attribute level preferences. It is technically complex to calculate, but it is done when it is relevant. Benefit transfer method, BTM, is another very commonly used method. What it measures? It measures the values transferred from existing studies. You are doing a study, for that you are not having data. You can transfer data or values from another study. But you have to understand the limitation of these two different contexts as well. The approach is applies unit values or functions from similar ecosystems. It is best used for large-scale assessments, rapid appraisal. It has requirement of the published valuation studies data. Limitation, it is low cost and fast, but it is not that reliable. It's having high uncertainty and side differences have to be taken into consideration. So we have discussed first 8 methods and now we will come to the second one, that is the total economic valuation. That's the last economic valuation models which we said that we will be discussing. This is a comprehensive framework, this total economic value method. It is used to estimate the full range of economic benefits provided by ecosystems by aggregating all relevant values types, use and non-use value, both integrated. TEEB has become a foundational concept in ecosystem service valuation, informing decision makers for resource allocation in environmental economics, also in natural resource management as well as the policy. Components of TEV. First is the use value we will be discussing, which is the benefits derived from the physical or functional use of the ecosystem resources, and it includes direct use, indirect use and the option value. Direct, as its name suggests, goods and services consumed directly like timber, food harvesting, recreational activities. Indirect use, services supporting or regulating the ecosystem functions like climate regulation, flood protection, water purification. So, directly we cannot really give a price for them. Optional value, value placed on maintaining the possibility to use an ecosystem service in future. So, we are keeping that option open. If I have a river, riverine plain, the floodplain, we are keeping open so that in future we can take care of it for several different things, whether for resilience, whether for recreation, those decisions can come later. Like in this case, the example is biodiversity for future medicines or utility. The second component is the non-use values, NUV. These are the independent of any current or planned physical use, rooted in ethical and altruistic considerations. So, the first one under this non-use values comes under the label of philanthropic value. Under this, we will be discussing bequest value, the value enjoyed from ensuring future generations have access to resources and ecosystem benefits. So, you are keeping something for your future generations. And the second part of this philanthropic value is again philanthropy, again altruistic, the value gained from knowing other people benefit. So that means you don't know those persons, but you are keeping something for them, sometimes grouped within the bequest or existence. The second part is that existence one, which is the satisfaction from knowing that a resource or ecosystem continues to exist. Suddenly, a particular species have been discovered in certain forest. So that becomes an existence value, valuing a remote forest or endangered species. So that's the way the non-use values are being categorized. So we can come back to this particular flowchart, which is bringing back all these discussions of this total economic value, use value and the non-use value, direct use, indirect use and the option. Under the non-use value, just now we have discussed the philanthropic value, bequest and the altruist, and the existence value, which we said that something we are not using it, but that is existing, that itself is having a value. So now we will be going forward to see how we can really calculate or estimate it. So this is the common expression where total economic value is actually getting estimated using the use value and the non-use value as we have discussed. Direct use value, indirect use value and the optional value, and the non-use value, it is having the existence value, bequest value as well as the altruist value. These are the philanthropic ones. So the data required are physical ecological data, socio-economic data, survey data, like willingness to pay, existence and the bequest preferences, scenario information for option or future values. Those are the type of data required for this TEV. How to do this TEV? Identify all relevant ecosystem services and the stakeholders. Categorize service values, as just now we discussed that direct and indirect use. Select appropriate valuation techniques, like for direct use, you can go for market price, production function, travel cost, hedonic pricing. Similarly, for indirect use, for option and non-use, also you need to select the relevant techniques. Aggregated estimates, benefit transfer for rapid assessment, or when primary data is not available. Then we go for aggregated estimates. Next step is calculate annual or lifetime values. Then we come to the aggregate into the TEV. Sum of all monetized use and non-use values, clearly stating gaps or non-monetized categories. So if you could not do something converted into money, then you clearly mention them. Otherwise, bring everything in under the TEV. So we'll be discussing one case under this TEV, that is the mangrove forest from that Southeast Asia, Malaysia Peninsula. And the forest type is the lowland dipterocarp, peat swamp, mangrove, logged and virgin forest patches. So it's a forest, it is having many different type of flora and fauna. So the TEV will take care of first the direct use value, then the indirect use value, hydrological regulation, carbon sequestration, and the last one is the non-use value and the optional value as well. So for this particular case, these are the ecosystem services. We know them by now. Millennium assessment we have learned in last week class. So provisioning, regulating, habitat and the cultural. For each one of them, they have identified the indicators, and for each indicators, they have also identified which are the techniques through which it can be evaluated. So lastly, we can find that direct use value has come from this provisioning one, and it is also having non-consumptive, non-extractive part, which is coming from the one section of the cultural one, that is fund received, entrance fee, which are already monetized. So that is also coming here under the direct use. Under the indirect use, we can see the regulating one as well as the habitat one, that is coming under the indirect. And the cultural, the second part, is coming in under the non-use value, existence, altruistic and the bequest value. So it's very interesting. Please read this flowchart carefully. You will be understanding how to do the TEV. Very quickly, let us go through this particular analysis, and after TEV, indirect use value dominates in this case. Existence value is very significant. So something is existing, that is very important for this particular patch. Direct use value is relatively small. That shows that it is having the virgin forest as well as entrances are not that open. Option value is smallest. Grand total is coming something in US dollar, which is huge for the mangrove forest. So the policy implication out of this particular ecosystem service valuation is like indirect ecological functions provide the greatest economic justification for conservation, vastly outweighing direct harvest value. So this indirect use value, which is coming whooping 86+%, that is the most important one. Now we will come to the socio-cultural valuation models for ecosystem, and here also several models are available. We will be discussing SOLVES. SOLVES is a GIS based model tool. Its purpose is quantifying public perceptions of ecosystem service value, highlighting cultural and social values, which are often overlooked in economic or biophysical assessments. So it's very important. which cannot be the intangible part of the ecosystem service. Those values are being captured. Integrate spatial survey data with the environmental variables to generate high resolution maps of social value distribution across landscapes. The focus is especially strong for mapping non-monetary stakeholder defined services, aesthetics, recreation, education, spiritual, life sustaining, biodiversity, therapeutic, or historical, cultural. So these are the values. What are the type of inputs we need to use solves? Spatially referenced public survey data you need, stakeholder attributes you need, environmental data layers like land cover, proximity to features, elevation, habitats that we need. Study area boundary data like GIS shape file of the analysis area, that is also necessary. The methodology is survey and mapping. Public stakeholder groups locate high value areas for ecosystem service. We will go for a wonderful example to understand that. Data integration and the social value indexing. This is very important, this VI, value indexing. So kernel density analysis and normalization of value point density for each service. So this value index is a standardized 0 to 10 score for each grid cell indicating relative value intensity. So that's the way the society shows their valuation. Next step is the statistical model linking. Whatever we got from the society, now we bring it back. And we use maximum entropy modeling, MaxEnt, to relate these value index patterns to environmental predictors like distance to water, land cover, elevation, and we generate the generalized models for mapping and transfer. Last part is the output mapping and the value transfer. Produces service-specific social value maps, stakeholder group maps, and quantifies how different landscape features like distance to water, trail, walking trails influences the social value distribution, even presence of a temple, how that influence. So this enables transfer of these patterns to similar sites. That's the value transfer function, which we have discussed earlier also. So there are two parts in this solves. One part is you are mapping the value. So for that you need your user group. They will select, they will communicate their value system through that value indicators, and then those information will be mapped through the MaxEnt model, and it will be also predicting as well as it will give us the maximum value. So that is social value mapping and environmental variable statistics. So you are mapping it for a particular area. And we will also see the same technique can be used for transfer value tools as well, as a transfer value tool. So when we use it as a value transfer, again you go for you select the user group, stakeholder group and the social value applied to environmental layers. And then your MaxEnt predictive model, which is there, that is really helping us, and we are getting that how in another case those particular experiences can guide us to get the predicted social value map and environmental variable statistics. So in this case, we are transferring the value to another area. We are bringing the experience from one area where it has been mapped directly. So that is the solves. Now we will see one particular case from China. There is an urban river, and this is a corridor of the river, and we will find the river corridor which is having lots of parks, riparian habitats, recreation sites, and local people are directly using it. Local residents as well as the visitors are directly using this particular landscape area. So in this case, the survey data from 300 plus residents and the visitors were being collected, For the spatial survey, marking locations which they value for 7 social ecosystem service types: recreation, aesthetics, educational, historic, biodiversity, life sustaining, and therapeutic value. So these are the 7 ecosystem service identified. Environmental data was brought in, like land cover, proximity to water, if there is any walking trails, elevation, and dominant habitat types on the GIS platform. Then the SOLVES workflow, stakeholder groups, they defined and surveyed the preferred location. Kernel density analysis was calculated. Value index, which the society is actually contributing, that was generated and normalized over every grid cell along the river corridor. And then next, those value indexed data was brought on the Maxent modeling platform. And these statistically linked environmental predictors like distance to water or the trails to social value patterns. So, sort of explaining why. This is that particular site for which this SOLVES model were being applied to evaluate the ecosystem service values. So the results came like spatial value index, the value indicators, recreation and aesthetic values picked closest to the water bodies, with many cells scoring more than 8. Biodiversity and educational values clustered in parks and naturalized riparian zones. Environmental variables explained up to 62% of the spatial variation for recreational value and 56% for biodiversity value. So now these reasons that if this particular space has a high value, why? Who is actually contributing to add that value? That was being analyzed through this spatial value index. Stakeholder insights, like recreation group has a different opinion, whereas the conservation minded stakeholders had different opinion. So that also came into the scenario. So the scenario was used through the maps which inform the planners where new amenities or conservation efforts would best align with the public values. So this is a very good way to actually bring the public perception into the planning of any urban area. So we'll be now coming to the last segment, that is the integrated one, and there we'll be using the TEEB. So the TEEB, as we talked about it from beginning of this module, is a comprehensive global initiative to provide a standardized framework for recognizing, assessing and valuing ecosystem services and biodiversity in economic terms. And we have discussed about it, how it was initiated, launched in 2007. The scope is over 2,500 studies have got its application. Worldwide, it's having a valuation database and operational guidelines. It provides for the policymakers, businesses and citizens, and that made it very popular again. How it works, the conceptual framework, it recognizes the wide range of services and their values, demonstrate the value explicitly by mapping and quantifying, and then capture that value by integrating the results into policy and decision making. So this is the very brief conceptual framework for the TEEBS technique. The TEEB does is the ecological assessment, quantifying and the mapping that service. Then valuation and integration, apply those multiple economic valuation methods depending on the context: market price, cost based, revealed or stated preference, benefit transfer, total economic value, all this. And then you can bring it into the scenario analysis and the decision support, which incorporates uncertainty, trade-offs and spatiotemporal dimension. What are the outputs type? Spatial maps and tables showing the distribution and the magnitude of ecosystem services. valuation summaries we get in the monetary terms, and decision ready analysis, which we were discussing in the last slide as well. Cost benefit comparison, incentive and compensation frameworks, guidelines for integration into national accounts or corporate strategies. So there are n number of examples of TEEB cases, as just now I mentioned. So very quickly I would like to go through this Sundarban one, which was one of the very extensive work of TEEB team. They have identified all four services: provisioning, regulating, supporting and cultural. Then they have tried to utilize the TEEB valuation system, and they could find that mangrove forests deliver the highest economic and ecological value among all land cover types in the Sundarban Biosphere Reserve. So that's a very strong observation. And substantial decline in ecosystem service value also was noted very strongly. This particular study also found that carbon storage dynamics is really going for the negative side, and service wise trends identified for the provisioning one is slightly increased, regulating, supporting and cultural are decreasing. So today what we have discussed the economic one through the case study of the mangrove forest from Malaysia. We discussed the socio-cultural one solves through the China case, and integrated valuation methods for ecosystem service, and here we have mentioned the TEEB for and also the Sundarban case. So these are the references. Thank you.